I'm Steve Lowe, as it says, ex-Director of Technology at Paddy Power Betfair. Technically true next Friday, but I am still employed for another 5 or 6 days, but nevertheless, I am moving on. If you want to know why, you can talk to me afterwards over a beer and I will explain in great detail. Maybe a few beers, we'll see. First of all, a bit about Paddy Power Betfair. Lots of people don't know much about us other than we're a bright green shop and we send out fairly annoying commercials quite a lot. We are in the FTSE 50, so we're one of the biggest companies in the UK. We're actually bigger than Tesco's or Sainsbury's, bizarrely. There you are. We have 800 engineers, software engineers, QAs, performance guys, systems engineers, 800 engineers, spread across 4 locations, London, Portugal, Romania and Ireland. Our entire estate is built up of about 300 microservices, which build our platform out underneath us. We have 2 million active users daily. We have 120 million daily transactions, so that's actual bets placed, or actual transacting. And our API does 2.7 billion API calls a day. It's a reasonable number. And we log 2.5 terabytes of data every day as well. Interestingly, obviously we don't read all of that. There are plenty of systems look after it. And our P95 transaction time is less than 4 milliseconds measured from the edge of our network back to the edge of our network. Right, so that's the cycle time. Obviously, internet we ignore because that's far too difficult. Normally we do around 500 deployments a week. So that's 500 changes to microservices a week. Although we did do a software-defined network upgrade a few weeks ago and redeployed an entire data center. Hence, we did 500 in one day at that point. So the technology is quite good, the scale's quite big. If you go and visit one of our shops, you will not see any evidence of this technology. It looks terrible because we're not investing in retail, but the online platform is much better. So that's just to give you an idea of the scale of the problem we're looking at, really. So what is DevOps? I stole these 2 pictures off Wikipedia earlier on. As I'm on gardening leave, I have lots of free time, so I'm spending a lot of time reading LinkedIn forums and posts at the moment. And there's a massive debate going on about every time I go to a DevOps conference, people talk about automation, and DevOps isn't automation. Well, I think, unfortunately, DevOps is kind of being tarred with the same brush as Agile. Right? It's like, you must do Agile with a capital A. Right? This is how you do Agile. It's kind of the whole point of this is it's adaptive to solve your problem. Right? These 2 pictures I thought were really interesting, as I said, stolen off Wikipedia. One indicates that DevOps is in the middle of all of these things and conjoined, but there's lots of stuff outside of DevOps. Kind of an interesting take. And the other one still has Dev and Ops fairly separate, even though there's a kind of cycle going around them, which also I find a little bit strange. I'm not a big believer in textbook DevOps. I like reading about it and hearing about what other people have done. Fundamentally, I'm trying to solve a problem. Right? So the first thing to do is define your problem. And our problem was pretty simple. We wanted to get more change in front of our customers faster, reduce cycle times. Right? We wanted better performance, or at least not degrading performance while we're doing it. And likewise, stability. For us, it was actually more stability. We had a fairly terrible infrastructure stability problem going on that we needed to fix. But at least you don't want to go faster and break everything. Right? And so you need to actually keep the stuff running so the customer can see it, particularly in our space. So for us, if we go down for a minute at the wrong time of the day, that's a few £1 million lost. So we're very keen on uptime, which is one of our key metrics. So given that those are our goals, right, more faster change, better performance, and more stability, reliability, what did we do? We started off with our normal stuff, a big backlog of stuff. We merged what we call delivery teams, right? So dev, QA, performance. So basically our Scrum team consists of all of the people needed to do all of those steps, right? So the output from a Scrum team, from a sprint, if you're still doing sprints, or from a cycle, if we're more Kanban-y, is a completely tested and performance tested application, piece of software, microservice in most cases. Because we wanted our teams to feel some ownership and actually some control over that, effectively we made them masters of some of those microservices. So with a little bit of quick maths, right, 800 engineers, Scrum team size of roughly about 8. That's about 100 teams, 300 microservices. Awesome, 3 microservices per team. If only it was that easy. But you get the idea, right? That each team will own a number of microservices, normally in an area, And they will have final say of what happens in there and complete control over that software, which was great, apart from when you deploy them, you have to raise a ticket. It's like, I want to add some more width to my service, right? I've made a change and I need to add more nodes. So I need to add them to my load balancer. But I don't have access to the load balancer. I need to go to my network team. So I raise a ticket to my network team. Awesome. They're really fast. They do it within boom, it's done. But it's not really done, right? Because inevitably, you've raised a ticket which has got, the briefest sentence you can possibly write because you're in a rush to make that change. Network team has gone, oh, I think that means this. Banged it out. It's not really what you wanted, and you go around the cycle again, and you raise another ticket until eventually you get it right. To exacerbate the problem, obviously there's lots of people raising tickets, and they all go into this big queue. Everyone becomes unhappy. Dev guys are unhappy that they've promised deadlines that they're not meeting because the network guys have held them up. The network guys are going, you keep giving me these tickets with not enough information. Round and round we go. No one's happy. That does not make a DevOps culture in my book. Right? That's a DevOps battle. Right? That's an adversarial approach to the problem. So, given that in mind, obviously we could take out raise the ticket step and get them to talk to each other. It's a nice idea. But still, there's still 100 dev teams and 20 network guys. That doesn't really scale either. There'll be a big queue of people at their desk asking for change. So you can't really do that either. So we looked at it as a more holistic problem, rather than looking at kind of infrastructure and this. And I've used networks, right? This actually applies to lots of areas, but networks is an easy example to get your head around. But we did it in all the departments in the same space. If you reverse it and do it this way, then you basically make your delivery teams self-serving. Right? I can now make that change myself. Right? Awesome. Now, unfortunately, all of our devs are not network experts, and we use various different types of load balancing. So we could train our entire dev team to be NetScaler experts, and then next year when we change to F5s, we make them all F5 experts. That seems like a really expensive and awkward way to do things. Or we could abstract that away from them, and we could build some tools. Now, for those of you lucky enough to be in an AWS or something, someone's already built that for you, which is perfect. Unfortunately, as a massively regulated industry, we have regulators who like to put stickers on physical boxes and say, this is running on this box, and this is running on this box. So we have to have our own data centers, which means we need our own solution for this problem. So those tools are actually a combination of build and buy, right? OpenStack stuff in there, we've built some modules, there's a whole bunch of stuff. A different presentation for the technical detail. But of course, we still need that network expertise to be able to configure those tools to put rules in place so our devs can't do something stupid like, route all of the internet's traffic to one node or anything crazy like that. Or worse still, if you give firewalls into that network space, access any to everything, and then all hell breaks loose. And we're on the front page of the Sun. 5 million user accounts hacked, credit card details. We don't want to be there, right? I certainly don't want to be standing up in front of a bunch of angry reporters explaining that one. So we need to mix and match a little bit. So we need skills in the teams. So our dev teams do need to learn some networking skills, right? You need to understand a little bit how traffic flows and how packets flow. And our networks guys now are actually producing product, right? Software, or at least scripting of some sort. So they actually need some dev and QA kind of influence in there as well. The QA bit was really interesting for me. So I, as part of my roles at Betfair, I took over and ran the infrastructure team for a little while. And we came in and it's like, brilliant, okay, we're going to upgrade our NetScalers. Brilliant, where are we testing them? Well, we can't test them because we don't have them anywhere other than production. Well, why not? Well, we couldn't really afford to buy an extra one for Dev and Test. It's like, okay, this is interesting. Or the one in Dev and Test is 6 versions behind the one in production because we never got around to upgrading it last time, or the 1,001 reasons you didn't do it. That was terrifying. Right? If you come from a dev background, we had fantastic CD pipelines. You check stuff in, it goes through a bunch of testing stages, there's an integration test, and eventually you get to production. In our network space, I log into a production box and I make the change by hand on the production box. And if it breaks, I panic and type in another command to quickly try and get it back and hope to hell I can actually recover. Or I actually bring the node out of service completely and let the others take the load while I try and work out what went horribly wrong. Didn't seem like a particularly sustainable, particularly given our goals. One of them is stability and uptime. you need to do that, right? So by building tools, automating a lot of this stuff, it's repeatable. Right? As part of that tooling, we did build a lot of virtual stuff as well, so we could actually spin up equivalent hardware, or virtual hardware at least, and test some of these rules as part of it. And by putting that dev and QA and the mindset of people who've written tests and done pipeline development into that team, they start picking up some of those behaviors as well. So you start getting the same kind of pipeline delivery for your infrastructure that you had in your software. And your software guys, apart from also learning about networks, also realize what they do, the software they develop and why it's painful to run on the network. It's like, this one where the port changes every time you run the program is a pain in the ass for a firewall, right? Because you now have to reconfigure your firewall every time. When it's someone else's problem, it's not really. It's like, oh yeah, we'll put it at the bottom of the backlog. We'll get around to it at some point. It's a defect. It's fine, but there's a workaround, which is phone the, you deploy it, you let the network guy pick up the ticket, and he'll fix it because it's an emergency because something's broken. When it's your problem and it's inside your team and you understand it, you tend to fix those problems at the root cause. And the main part of the shift here, apart from just making those things there, is that you're solving the problem in the right place. Right? So now these guys can go, oh, actually, I now see how this is causing a problem in this space. They can talk the same language, right? There's not that barrier because actually your network engineering team is now much more like a dev team, right? You've got devs, you've got QA, you've got tests. They can talk the same language, and they can talk about the same things. Breaks down a lot of barriers, right? Which makes it much easier to carry on going forward. So, how do you do that? Well, the importance of T-shaped people. You may have heard of T-shaped people before in the past. Obviously, you can, in every Scrum team, you can have a QA engineer, you can have a Java developer, you can have an Ansible guy, you can have a performance guy, and you have a network guy. But if one of them goes off sick, you're probably stuffed, right? You've probably annihilated your team because you can't do that. So you really need people to have a breadth of skills. They don't need to have the same depth, right? You'll still have a Java expert, right? And you'll still have a networking expert, and you'll still have all of those things. But actually, you want them to have a little bit of knowledge of other things as well and be able to help out, right? Comes back to agile practices in a lot of senses. I think there's a lot of comparisons you can pull in DevOps. If you bring all of the infrastructure stuff and the operation stuff into the agile framework, you get a lot of the same patterns reappearing, right? So it's actually, if I've got my team and Bob's on holiday, right? Bob is the best Java developer. That's awesome. Anyone called Bob? Something just, and no one's getting insulted while I'm talking. Good. But when he's on holiday, it's okay. Our QA guys who now have nothing to do because Bob is no longer producing code for them to test, right? Well, they can chip in and write a little bit of code, right? They won't do the complicated stuff probably, or the really hard stuff, but there's a lot of code that goes on that isn't that complicated that they can still churn through. You can still churn through stories, and it means that your team becomes a lot more predictable, a lot more stable, right? You then throw in the ops elements into there as well, and all of a sudden you now don't have any other third dependencies, right? You've reduced the number of dependencies, the unknown. Right, because no one, as far as I'm aware, in a planning session comes back and goes, okay, what about networks? Yes, we're going to do all this software change. We should really talk to those infrastructure guys. We certainly didn't. We were terrible at it, right? It was like, oh yeah, we'll have that done in 3 weeks. That's awesome. At the end of 3 weeks, oh yeah, we've given it to the operations guys. They said it's going to be another 4 weeks because they've got to buy some hardware or something like that we didn't talk to them about. If it's all controlled inside your team, right, that's a much more interesting thing. I've drawn the team as flat, right? So if you take then all of your skills and all of your people, it's important to know that people are not Java developers or they're not QAs, right? They are people. And as such, they have different histories and different backgrounds. So if you put 2 Java developers and you drew a picture like this for them, they would be different, right? They might both have a very long Java line, you would hope. If they're Java developers as their main profession, you would hope that would be true. But one of them may have had some systems experience, so is much more familiar with networking and Ansible and things like that. And the other one may have come from a QA background or worked in a much more test-driven environment, so those have longer lines. So then if you look at those, when you combine them and to build your team, you can also get a shape of your team, right? So you can go, oh, actually, look, here, maybe I've only got one guy who's networking, any networking skills. I probably need to rebalance that and put someone else in that team with some networking skills so I'm not bottlenecked. I've drawn it flat. Actually, it tends to be, you really want more T-shaped teams as well. So actually, you really want a team that is probably Java and QA for a delivery team, software delivery team, and then a little bit of everything else. And if you go the other way, for the guys who are building the tools, it's probably whatever their tooling expertise is, so a long networking bar and a little bit of dev and QA. But fundamentally, you can build teams in there. You get a very easy visualization of how your team's doing. It's very handy when you're hiring people because you know what kind of person you're looking for. You know, oh, this would be great if I could find a guy with a little bit of networking skills as well, or a little bit of whatever. And you can keep your teams much more balanced and looking forward. As part of this whole transition, the other thing we did, which is very important, is we put all of our devs on call. So there are no operations anymore. It's not true, there are an operations desk that runs 24/7, but basically they call out the delivery teams. So you are responsible for your component. So you deploy it, because now you have full control to deploy it yourself. You own a set number of components, which we talked about at the start. So now when they go wrong, it's entirely your problem, and you have all of the skills in your team to fix it, and all of the tools to be able to do that. That means all of those rules and regulations that people tend to put in big companies, right? When you get to this size, people like putting rules in to try and fix things rather than trusting people, which is an annoyance to me generally. But it's like, okay, Friday afternoons, you can't release on a Friday afternoon, right? Perfectly sensible rule, because no one wants to wake up on Saturday morning and have to fix lots of bugs from the software you released last night, particularly as Saturday is the busiest day of the week for us as well, so that doesn't really help. But of course, if your team knows that it's them that's going to be called, they're not inclined to deliver on a Friday afternoon or anything that they think is risky, right? And that whole balance of pushing software on a deadline versus actually, should I actually just take another week to finish it off and make it more stable? You can let the teams, you can trust the teams more to do that. That in turn empowers the teams more. The teams then feel more ownership for the whole thing, and you get this kind of virtuous circle going on in that space. So that's really the end goal. What it looks like a little bit, and this is a terrible drawing, I apologize, but basically we have lots of independent teams. Sometimes they work together, like here, to an outcome. Some teams produce an outcome which provides tools for other people to use. But there's lots of independent things going on. Obviously, when you've got 800 engineers, you can't have everyone working on the same thing. Otherwise, there's a lot of overlap going on in that space. So you have all of these independent things going on. We have integration checks going in. The bit we're missing, the next step for us, is this is all great until this team over here wants to make a change to this, but it's owned by these people. And you don't have a mechanism for that. It's like, oh, no, let's fight. We're not going to do anything very brilliant. We're going to steal the open source model. Right? Basically, these are the guys that control the branch. You can submit patches to it, and we're going to make it part of their objectives to accept patches. So there will be a back channel. If I'm using a tool, and I go, oh, it would be better if it did it this way, a little bit of discussion with the guys, submit a patch. You can do it, unless they've got time to do it themselves, obviously. Generally, everyone has a backlog, right? And it's very hard to slot anything in. That would then give us, hopefully, the complete picture. Unfortunately, I'm not going to be around to see it, but I'm trusting that this will happen. And then you will have properly empowered, self-contained teams as much as possible who can get on and do stuff. There are some overheads. Right? Unfortunately, it would be nice if you could just leave it and let them get on with it. But unfortunately, you do have to have a bit of guidance. So there are some things that are golden that you can't change in your team. Interfaces. Right? So your service provides an interface to other services. You can't change that without going through an architectural review. Sorry, haven't found a more efficient way of controlling those dependencies. Such is life. Introducing new tech. So you can do library updates and stuff, but if you're going to introduce new tech, we have a rule, you can only have one experiment running in one space at a time. So you can't introduce 5 new databases at the same time. So if you want to propose, you can go to the architecture board, literally phone one of them up and go, is anyone experimenting with new database technology today? No? Brilliant. The slot's open, you can experiment with new database technology. If someone's already experimenting, you have to wait for them to finish before you can move in. It's a bit blunt. It's, again, the best we can come up with to try and get governance that you don't end up with 900 different technologies. While it's a nice idea that everyone can be fully independent and use whichever technology they like, when you want to scale out, when you want to change things, when a team half disappears because they found a better role or something more interesting to do, and they've used an entirely different technology than anyone else in your organization, we can't really afford to let that happen. So there has to be some governance wrapped on it, but we try and keep it as light as possible. It's mainly an architectural In a Spotify term, it would be a tribe, right? We have some over-governing architects. There's embedded architects in each kind of area, so every 3 or 4 teams has an embedded architect that works with them closely, and they meet every few weeks to push those things through. I'm almost out of time, so I'm going to go to questions. That was the fast overview. Are there any questions? Okay. Thank you. Oh, Baz. It's going to be a deep technical question. I can feel it coming. No, okay.
I'm interested in the bit where you change the teams. So when they are used to working in the way the teams are always used to working, and then you change it to a completely different team in terms of that cultural change. How much pain was that, or did it just make sense to a lot of people?
It's a mixed bag, right? So I would say 75% of our people took it on as the way, so people have seen the AWSs of the world, the cloud. Our future is probably AWS, right? Once the regulators kind of finally catch up with technology, we probably won't own a data center, and that will be the kind of path we go down. There were resistance, right? There was definitely people who said, no, my job is I am a Cisco certified engineer. I spent 8 years getting this internet certification. I don't want to learn anything else. Okay, sorry, but we don't really have a use for you. I'm afraid it's a bit harsh, but actually it's changing, right? And I don't need a lot of deep knowledge. What I need is a lot of people who can make changes and a lot of automation to take that. We did find, during our search for software to provide that tooling box, we did find some guys who a product called which hooks into Cisco and Arista and all the popular vendors, and you go, I want it to look like this, and they apply the configs for you automatically. And if it's not wired the way you think it is, it will tell you need to change these 2 wires around. It's quite impressive. Again, if anyone wants details, come and find me afterwards. I'll try and dig them out in my email. But again, a lot of that stuff is automated. The deep knowledge, I'm afraid, is less and less valuable. A breadth of knowledge and getting outcomes is the big win. It's a very long answer.
Over the left-hand side of the room, I guess, right-hand side.
Depends which way you're facing.
How did you determine when you're working through which individuals have the right skills? They may have many skills, but how do you work out which are the right skills for the jobs that you've got?
It's a fairly good point. I mean, there's a limited set of things we change, right? So, I mean, all of our staff pretty much Java apart from our website, which is JavaScript. So there's some skills that kind of automatically fall out. When we did the transition, right, so there's a lot of people who didn't have the skills, we offered a lot of training, right? Was the simple way. It's like, look, we know you can't do this today. This is where we want you to be. We are going to provide training. So we went out, we got outsourced. So we went to Computer Center, we went to Red Hat. We got some guys in with some expert knowledge in the various bits we needed. We brought them in for the dev and test stuff. Well, with 600 of our 800 engineers are dev and test experts, so we've got our own internal resource who can teach some of that stuff as well. But yeah, it was definitely when at the start of the transition, it was, this is what we're going to do. You can be part of it, and we will provide training and coach you along. And if you don't want to be part of it, I'm afraid, sorry. Yeah. But it is very hard to hire people. The industry, for some reason, I still find this amazing. I started in a very kind of small startup kind of culture. So I applied for a job as a sysadmin. I got a job as a developer in the same company, which was a bit weird. 2 months later, I was sysadmin after 2 months of development. So I'd done all of these things. So when I came to a company, I was like, I remember my very first day at Betfair. Very quick story, I promise. I'm going to run out of time. First day at Betfair, I was making a change. I went to the database, add a column to a table. Right, brilliant, I can do that, no problems whatsoever. Slapped on the wrist, no, you're not a database developer. You can't make a change to the database. And I was like, seriously? It's like, but why? No, it has to be a database developer that makes that change. And they were everyone was in these very strict silos. And I find more and more people seem to be in these very strict silos without looking out wider. I think more and more, as time goes on, looking wider rather than narrow is going to be the way forward. again, a very long answer.
Are the teams have 100% access to the live environment? I mean, when you say, okay, you
So,
have accessibility to deploy that on
They
live
can't,
as well.
SSH in, they can deploy, so they can go through the pipeline to deploy, but they can't actually access the box. So we have all the log collecting and all of those things. That's not true. They can access, but there's a break glass, right? There is an automatic response ticket. You raise the ticket, it will give you an automatic root password. It will log the event, it will trigger PIR afterwards. So we'll do a post-incident review on why you asked for a root password. But yeah, so fundamentally, yes, they can deploy to production, because actually if it breaks anything, well, they're going to have to fix it. They're going to be called out. It's their job to fix it. They can't actually SSH onto the box directly. Yeah.
Thank you.
Patrick's got some insider knowledge.
Just two questions, probably short ones.
Okay.
How much of the tooling was written in-house? How much of that was already there, provided by various other providers?
Yeah, it's a good question. I think probably about 60-40. So about 60% of it is stuff we bought off the shelf. Well, it's a lot of open source stuff, actually, a lot of OpenStack contributions, Jenkins, tools that everyone's familiar with. 40% of it is stuff we bolted on top. So there's a lot. If you go and check the Ansible repository, you'll see an awful lot of check-ins from Betfair, particularly around load balancer automation and things like that, where we've upstreamed all of it back into the open source community as well. So yeah, about 60-40, I think. Question two.
Question number two, how did you solve the problem of having access to production, similar to production load balancer?
The regulation challenges or the...
Was that a virtual one? You just bought a new one of the same, or that was a...
So we actually abstract away our load balancing. So we actually create an independent YAML file which describes all of the features of our load balancing that we want to expose. And then actually underneath it, at the moment, there are still some NetScalers, there are some F5s, and there is some Nginx in there. So actually, we've got 3 plugins that turn it into whatever we need. Means at some point in the future, when we finally get access to Amazon and allowed to do this stuff, we'll just convert those YAML files to ELB and away we go. Yeah.
Hey, sorry.
Cool.
More from, I guess, an organisational standpoint. So when shifting over to like T-shaped teams and sort of establishing people that have like a breadth of responsibility as opposed to deep knowledge, did that kind of redefine for you, like, I guess, specific engineers' performance, like what would make, like, say, a mid-level engineer, senior engineer, etc. And I guess how would you handle that with people that are already there, say, in senior positions that suddenly had to like upskill or expand?
Yeah, so it did change our measurement. So we do have kind of ideal T's for people. So everyone has a kind of picture of their own T shape, and we have ideal T's. So seniors, the more senior you are, we want more breadth as well as depth. Same as the other. A few with much less dissent in the development community, but there's a handful of people who wanted to become the world's best Java programmer and wanted to focus all their time on that. Okay, wasn't the place to do it. Right? But again, the same thing. Training is the way. So you are here. You have 12 months to get to this position, an agreed kind of intermediary position, if you like, and another 12 months to get to it. So we give people time to transition, I guess.
Time for just one more question. Is there one there? I just one question about load balancing. So you mentioned that you had a sort of YAML file which would expose the bits of the different load balancers, Nginx,
Yep.
and so on that you wanted to expose. What would be the reason for doing that, if not to, like, I assume the reason for having different load balancers is to exploit the features of those load balancers rather than making it sort of lowest common denominator across
The reason we
them all?
ended up with different load balancers was a cost reason, actually, not a not a technology reason.
Okay, fair enough.
But yeah, I mean, we exposed, so there's a common set of things we exposed, which are, the SSL type stuff, the basic load balancing, adding things to pools, removing pools, that kind of stuff. Anything that we only have 1 or 2 more exotic rules that are still manually done. Our aim is to simplify. Right? So again, as part of this, where the dev team own the whole thing, including the load balancing rules, if you can't express your load balancing rules in a simple enough format, then you should probably change your system to be able to express them in that way. And it makes that very plain to the engineers as well. Yeah.
Thanks.
Cool.
Thanks very much for everyone for your questions. Cool. Are you hanging around? Are you
Yeah, I'll be around.
If anyone else has got any questions they didn't get a chance to ask, then just grab them in the break. Thanks very much, Steve. Cheers.
Awesome. Cheers, guys.